Good evening. Once again, this is Mr. Steele, and I'm here once more trying to help you with standard quiz questions from the Term 3 and 4 standard quiz at Franklin High School in Algebra 2. This time I'm going to tackle standard number 8, which deals with evaluating logarithms, finding the value that a certain logarithm represents. And the way we're going to do this is with the strategy of common bases. So again, I'm assuming that you've had the lesson already in class, so if you're in my Term 4 class and you're kind of trying to cheat and get ahead, not that there's anything wrong with that. Good luck. We'll get to this at the end of the first week. For everyone else, hopefully this is just a nice refresher. So first of all, our key idea here is that we're going to try to evaluate logarithms by finding common bases. In other words, these guys are always going to be nicely created so that you'll be able to rewrite them as the same thing. Basically, the idea is if you have 3 to some power and you don't know what it is, but that's equal to 3 to some other power, like say a number, then what we know is the thing in there has to be that same number. Those powers have to match when the bases are the same. And so that's going to be our entire strategy here. So we're going to first get out of the logarithmic form, and then we're going to try to match the bases together. So looking at these two pieces, base 9 and 27 being involved in here, you should probably be thinking that the base is going to be 3. Like it should be 3 to some power equals 3 to some power. That'll be our goal. So second among that is what the log notation means. So just as a quick refresher before we start evaluating a whole bunch of these things, remember that log base b of x equals y means exactly the same thing as this exponential. Base to the exponent equals argument. So each of these things will correspond to a particular part of an exponential equation. So our step is going to be exactly finding the log, or rewriting this log in terms of an exponential, and then finding common bases between both sides. So let's go ahead and get started. So I've already got the problem written in black, so I'm going to change it to a different color here so that I can make it a little clearer for you. And so here we go. So where I start, as I said, I want to rewrite this in exponential form, but right now it's just log base 9 of 1 over 27. We need to find the exponent. Well, remember that according to this notation, whatever thing is over on this side is going to become the exponent. So in fact, let's just call that exponent a variable. In fact, since we got y over there, let's stick with y. That's usually how I do it in class too, since sometimes our problems have x's in them. Okay, so from here, what we're going to do is rewrite it in exponential form. Base to the exponent equals argument. So in our case, it's going to be base to the exponent equals argument. And so there's our equation. We've just got to solve and figure out what that value is up there. What power of 9 is going to give me 1 over 27? Well, for right now, 9 and 27 don't work really nicely together. It's not like, oh, 9 to the third power is 27. Well, that's not true. It's not. So, and if you were thinking it was, shame on you. So instead what we have to do is we got to see and think, like what base is kind of hidden in here? Like what am I squaring or cubing or negative cubing or to the fourthing? Quarting? I don't know if there's a word for that. Whatever it is. Like what is it that's going in here? Well, what we know, like in your head, so let's call this is your brain. There's a medulla oblongata. I think that's what that's called. I haven't watched Waterboy in a long time. So what you're kind of thinking in your brain is, oh, 9 is just 3 squared. And 27 is just 3 to the third power. Well, see, those 3's are the same thing. So that's where we want to go. We want to rewrite this in exponential, or we want to write these with a common base. So in this case, we still got something to the y. We're still going to have 1 over something, but we can get a step closer by rewriting them with that common base of 3. So 9 is 3 squared, and 27 is 3 to the third. Now from here we haven't gotten to our answer yet, we still don't have it, but what we do have is an expression that can be transformed. Like we can manipulate both the left side and the right side so that they say 3 to some power equals 3 to some power, and then we can set the powers equal and do our thing. So on this left side we're going to take a power to a power. Power to power means we multiply the exponents. So this side is just equal to 3 to the 2y. So that's really 2 times y, but we say 3 to 2y. On the right side, using negative exponent rules, recall from, well, the last video I did, which was standard 5, that 1 over a to the m is just a to the negative m. So this thing, since we have 1 over 3 to the third, that's really the same thing as 3 to the negative third, which means that we now have common bases. We got 3 to some power equals 3 to some power. That means that the powers have to be equivalent. So this can't possibly be a true equation. 3 to the 2y equals 3 to the negative 3 can't possibly be true if y is just some random armadillo. Like, it has to be a particular number that solves this equation. Otherwise, they would not be the same. And of course, all we want to do is solve this one-step equation. We'll just make a quick little 0, or a quick little 1 here. Divide by 2. We get that y equals negative 3 over 2. Now what does that mean? That means that our equation, or our logarithm up here, log base 9 of 1 over 27 equals negative 3 over 2. So to write our answer, we don't write y. That was just our variable so that we had an exponent to look for. We just say that the answer, or log base 9 of 1 over 27 equals negative 3 over 2. And now what that really means is that 9 to the negative 3 over 2, let me write that in here, meaning that 9 to the negative 3 over 2 power equals 1 over 27. And in fact, that is true. If you don't trust me, you can go ahead and manipulate it a little bit, and you'll see that it does come out to be the fact. So in fact, as our answer, we get that negative 3 over 2, or negative 1.5, is our answer. That's the power of 9. That gives us 1 over 27. So that was one. Let's look at another one. Like, that's basically all we'll do from here, is just kind of look at some examples. And okay, so here is our second example. We want to evaluate log base 1/4 of 32. And of course, the question we're asking ourselves is, what power of 1/4 is going to give me 32? And now some people can do this in your head. Like, I do know a couple students from my first period class that can do this in their head. But for the most part, you want to do the work so that you make sure you don't make a silly mistake, because it's easy to transpose something or flip a number, or forget a negative sign. There's lots of little things that can happen here. So again, looking at this, our goal is once again going to be to try to find common bases. This time though, looking at what we have, 1 over 4 and 32, our best bet isn't going to be a base 3, it's going to be a base 2. So I'll just change it over here in my little strategy. Like, we want to end up with, based on what we see, 2 to some power equals 2 to some power. Of course, there may be another way, but it's 2 is going to be the nicest one probably. So looking at it, where we start is, once again, we set it equal to y. That's going to be that's our value we're putting in here. When we find y in the answer, that's just going to be this expression's value. And we're going to do that so that we can rewrite it in exponential form along this path. So base, our base is right there. So 1/4, I'll put in parentheses just to be careful, to the exponent power, that's y, has to equal 32. And so this is our setup. All we've got to do is transform this into 2 to some power equals 2 to some power. Well, the right side's really easy. It's just 32 sitting there, and 32 is 8 times 4, or 4 times 4 times 2. Either way you do it, no matter how you think about it or break it down, you're going to get 2 to the 5th power. There's 5 2's that multiply together to give us 32. Excuse me. On the left side, we've got 1/4. Well, that's the same thing as 1 over 2 squared, all to the y power. So now the right side's always just going to stick there. The left side, we're going to have to simplify a little bit more. It's not yet 2 to some power. So first, let's do the inside. Like, 1 over 2 to the 2nd power is the same thing as 2 to the negative 2 power, meaning that we can rewrite this as 2 to the negative 2 all to the y. And then following what we did the last time, power to power, we just multiply. We're going to have this as 2 to the negative 2y power equals 2 to the 5th. Well, once we're here, we're at our spot. We've got our common bases. That means the powers have to be equal to each other, because otherwise you couldn't have 2 to some other power equals 2 to the 5th. So in fact, our exponents, negative 2y and 5, must be equal. And from there, solving the equation is pretty much trivial. It just goes really fast. So to make a 1, divide both sides by negative 2, we get that our value is y equals negative 5 over 2. So now what is that? That means that the power of 1/4 that gives us 32 is negative 5 over 2. Or, just particular to here, that log base 1/4 of 32 equals negative 5 over 2. That's the power of 1/4 that gives us 32. And there we go. So we've got a second one under our belts. Let's just do one more. I think you probably got the idea. This is a pretty strong chapter test last term in my class. Okay, so looking at this last one, what you might see is that there's a little bit of a hitch that we might run into here, because we've got that square root. Like, we haven't dealt with the square root yet. Well, first, even before we start, since we know we're going to be using common bases to evaluate a log, we can look at what we have and think about what it is that's going to make sense here. 25 and 125, I think it's clear that the base we're going to want this time is 5. We want 5 to some power equals 5 to some power. So let's just start it off. Like, we can do this pretty quick. You've already seen the process. So we set it equal to y, because that's going to be our answer. We want to know what exponent, what power of 25 gives us this. And now let's rewrite it in exponential form. So base to the exponent equals argument. From here, let's just rewrite them in terms of 5s. So we want 5 to some power. Well, let's do the easy parts first. 25, I know 25. 25 is 5 times 5, so that's just 5 squared. And 125, well, square root we'll leave alone. 125 is just like 5 quarters. It's 5 times 5 times 5. So that's 5 to the third. Now we're not quite there yet. We still have to kind of finish this. We don't have enough yet because we have to deal with the square root. Well, we covered this in chapter 7, I believe it was. We found that the square root of x is really equal to x to the 1/2 power. If you don't kind of trust that, think about what we know about x. Square root of x times the square root of x equals x, which if we turn it into powers, that would be x to some power times x to some power has to equal x to the first. The only thing we can add twice like that would just be 1/2. So in fact it does have to be x to the 1/2. Well, using our power to the power stuff once again, the left side we can actually simplify. Power to power 5 to the 2y. On the right, we just said that the square root is the same thing as to the 1/2 power. So whatever it is on the inside, we're going to take it to the 1/2 power, and that will just give us the same value as a square root. Well, once again, we've got 5 to some power to another power. We multiply those exponents, and we'll get that the square root of 125 is 5 to the 3 over 2 power. And if you don't see that, imagine us putting a little 1 under there and multiplying fractions. So here, hey, yeah, there we go. We got what we want. Same base, same base. That means the exponents are equal. 2y has to equal 3 over 2. And what I'm going to do to get y alone is divide both sides by 2. Or, in this case, since we got a fraction on the other side, it might be a little clearer to think of it as multiplying both sides by 1/2. That way we'll still make a 1 with the 2's. We'll get y alone. And on the right side, we'll have multiplying across. 3 times 1 is 3. 2 times 2 is 4. And in fact, the value of our logarithm, log base 25 of 125, is 3 over 4. That means 3 over 4 is the power of 25, or the power you raise 25 by to get square root of 125. Or let me just write that since I said it so confusedly. 25 to the 3/4 power must be equal to square root of 125. And of course you can check that on your own, check it on a calculator. You'll see that they are in fact true. And so we have once again evaluated logarithms. Okay, that should wrap up the video. To kind of cover all that we did, we talked about the idea first, like what goes through your brain when you see a logarithm like this you're trying to evaluate is to think of common bases. You have to kind of look and inspect it and try to figure out what common base, what simple base would be a good choice to pursue. And then you just have to rewrite it in exponential form, which you do here. Base to the exponent equals argument, and then find that common base by using things like power to power or negative exponent rules, just so you get what you want, eventually solving for it. And of course that thing that you solve for represents the power of the base that gives you the argument. In our first example, it's pretty straightforward. We did see a negative exponent rule in action. In our second one, same kind of thing. It was actually probably even more basic than the first one, although we did have a different common base. This time we pursued a 2, and our base itself, 1 over 2, or 1 over 4, was a little bit different. Finally, this last one, we saw that last little trick that can come up, that square root. Well, just if you remember that the square root of a number is just that number to the 1/2 power, you can very quickly rewrite it the same way you would any other ones. And in this case, we're able to get our answer 2. So finally, I'm going to count on that being sufficient based on how well you guys do in class. So for the umpteenth time today, this is Mr. Steele signing off. Hey, that's me, just as bald as I am. Have a good day.